So here we are doing a temperature time transformation for iron carbon diagram, right? Temperature time transformation for iron carbon diagram, for iron carbon. Some of the things that you should notice are that you should notice the unit of the, the axis. Here we have everything in seconds and then in terms of 10 exponent, right? You should notice that. And then we have the temperature here, and then we have here in Celsius, temperature here in Fahrenheit, right? And then the other things the other things you notice is the boundaries, right? So basically on the diagram, we have perlite being night, right? Where the meet is here, we have it to be 550, right? So this line here, right? So everything above here is perlite, everything below here is actually benite, right? Then again, we have, what's the name? Upper benite and lower benite. For the upper benite, sorry, for the perlite, we have where the meet, that's for the, what do you call it, the fine and coarse perlite, right? So up to about, let's say, it's a conversion though, generally. So up to about 650, we know this word perlite, or this origins is for perlite, right? So yeah, this origins for perlite. So up to about here, right? Everything here is a fine, right? And everything here is coarse, right? And then for the benite, it gets up to about 2 something where this line ends, right? So all this region here is also benite. We are in the benite region. Yeah, that's how we see it. But then here, the meeting point is about like 350. So then about 350 here, everything here is, what's the name? Upper benite. And everything here is what lower benite, right? So here, you just have to notice these ones, and then when you are identifying the structures, you'll be fine. So we know the, what do you call, the perlite and the benite be here 550. Fine and coarse perlite is about 650, right? That's where they meet. And then the upper and lower benite is about 350, right? And then the martensite start line is about here. If you don't see it, you should just know where this is, and then you draw a straight line, right? Yeah. So these are some of the things you should notice. And then you should notice the time that is given for the conversion. If it's given in hours, find a way. If it's not given in terms of power turn, find a way to get that one. Okay. So now when we get on with this example, right? Then one thing we should notice that most of the time they give with a starting point of the whole transformation, right? So in this case, the transformation all happens at this temperature here, 750, sorry, 760 degrees Celsius or this, right? So notice the temperature unit that is given, very important, else you miss everything. So the first one is saying that we are starting from 760, right? So 750 is about here, 60 is about here, right? So it's saying the A says that we, what do you call it, rapidly cool, right? Then again, notice the side. This is from negative 10 to the power negative 1. So there's kind of like was in negative seconds, right? So everything here, doesn't count that much, but we just use the others, the, what do you call it, the starting point, right? So the actual counting is within this range. Are we okay? The actual counting is within this range. One thing I missed before. Okay, so now move on. It says rapidly cool to, cool rapidly to 350, right? 3. To make your work easier, 350, you know, is here. So we start from 760 and then rapidly cool to about here, right? And then what do we do again? It says hold for 10 to the power 3. This one is giving straightforward 10 to the power 3. We know where it is. It's on this line, right? So it's safe to use a ruler. That way your work becomes much more clearer, right? And then quench room temperature. Whenever we are doing a quench, meaning that we cool rapidly, right? So it's the same as cooling rapidly. So quench, right? Cool quench room temperature is about this way, right? So looking at this one, then again, remember where we are. We know that the boundary for, what they call it, perlite benite is here, and then upper and lower, what do you call it, upper and lower benite is about here, right? And then coarse and fine perlite is about here, right? So now we cooled from here, from the austenite region, came here, right? We are still having 100% austenite, right? And now we are in the, what's the name, benite region, because we are within here and here, and we continue and then we come here. The moment you cross this side, meaning that we haven't more than, we've converted everything to benite, right? So basically we haven't 100%. What kind of benite? It's actually kind of medium benite, because this is the boundary for benite, right? It's for, sorry, for upper and lower benite. So Not that important, but I just write it. Yeah, just a conversion. Day night, right? Now two. Let's make it A. Right? What's B saying? Rapidly cool to 625, right? So where's 600? There's 600. 650 is about here. 625 will be about here, right? So from this, let's make it clear. Then again, the ruler is safer, right? 625, what do we do? And then we hold for 10. 10 is clearly there. Ruler, right? Just trying to make it as straight as possible. So our predictions will be clear. Yes, okay. And then hold for 10 seconds and then continue temperature, right? So we are about here. This is what we have. Looking at this one, we had austenite, right? And then we cross the 50-50. So looking at, we can just say 50%, what do you call it? What, 50% fine perlite and then 50%, what do you call it? Martensite, right? But let me explain this. So we have austenite, right? And then we raise it here. We are still in austenite, having 100% austenite. Here is 50-50, right? I didn't say this. So here is where we start from, what do you call it? If we are within the, what do you call, the perlite region, here we start, we have an austenite. Then we have some amount of perlite. Then we get 50 perlite, 50% austenite. And then when we enter here, when we get to this particular point, we have everything of the austenite converting to perlite, right? When we are doing the straight line conversion something, right? So this line here, this blue line here is the 50-50 line. Okay, I didn't see that earlier. So here what's happening? We have an austenite and then we hold, right? We are converting. It starts here, start. And then when we get here, you have 50-50. But looking at what we are right now, it's cross the 50-50. So we can, no, and it's not hard, we can see about 75% has converted to what do you call it? What kind of perlite? Fine perlites, right? Then again, we are putting it in bracket just in case. So you can just see 75% fine perlite, and the rest has been converted to what? When you quench austenite straightforward, you get what they call martensite. So the rest will be about 25% martensite, right? And then what do we have for C? Let's see. C says we rapidly cool to 600, right? So we start from the 760 something, 600, right? And then what do we do? We hold for 4 seconds. We know there's 1 second. Here is about five here. So the four is somewhere around. So we hold for 4 seconds. That's see, right. It's about 4 seconds. Slightly more. 4 seconds, right? Uh-huh. You don't have to extend it to touch the center though, but just make sure it's about four because like when we check the four, when we draw a straight line from here, it's not getting straight. I don't have a ruler, so I'm using freehand. So you see that the four is about somewhere here, right? So we are maintaining that. Yeah. 4 seconds, what do we do? We are on B, right? C. And then now we cool to 450. Right. Whenever we do a particular hole for some time and then we are doing what do you call it? We are doing something else to a particular temperature again. We because we use time, we hold at a particular temperature for some time. Whenever you hold for at a particular temperature, you have to re-zero. That's how we say it, right? So that's what we are doing for. We are at C, right? So what we do for C is that we cool to this, right? We we cool to 600, right? And then we held it for 4 seconds, right? Now we are about to cool to 450, meaning we have to raise zero, right? So where's 450? There's 400. 450 is about here. So we do the raise zero in terms of time, right? So we bring it here, right? So that's what we do. What's the next thing? Now we hold for 10 seconds. So that's what we do. That's our 10 seconds, right? And then we then quench to room temperature. So quench to room. So that's about it. What do you think happened? So we have 100% austenite. Then what? Yes, we having about, so let's say 50, about 50% converting to what? What's the name? Fine perlite. So C, we have 50%. I'm using F for fine, right? F perlite, and then what happens? Right, that 50% that's remaining, which is still austenite, we don't do anything to it, just raise zero, and then that 50% comes here, right? So meaning we've converted 50% of it because we're in the bainite region. 50% of the 50 that left, right, which will be 25 to what? Let's see, where exactly it is it? We are now in the bainite, right? So to be upper. So we have about 25% upper. Let me write this so I don't want any confusion. All right, for now. 25% upper what? Bainite, right? Let's look at it again so we are sure. So we get here, we know bainite is reading this and then this, right? This, yeah, and this. And then we know bainite to be within where we end for this one, and then about here, yeah, about here where the matrix I start. This is the bainite region. So if this is it, this is where, sorry, this is actually where the upper and lower bainite meet. Then this line is here. Then we have an upper bainite, right? So it's clear. What do we do now? Now we have 25% this. So meaning that we have 25% of the austenite left. So all of it will tend to a martensite, right? So that's what will happen. So we have 25% because we quenched in the end. Martensite. Right? So now we'll go to C. C. What is C saying? C, right? Oh, we just did C, so we're on D. So now from the specimen in C, we reheat, right? Now that we've done to a particular temperature, we held and everything. Whenever you are doing a reheating or you are cooling to another temperature again, we do what? We re-zero, right? So that's what we do. Now we are reheating the specimen in C to 700. So this is where we ended, right? This color. Where's 700? This is 700. So straightforward. Minute. 700, right? And then what do we do? It says we hold for 20 hours, right? Then again, when we started, everything here is in what? Seconds. So how do we convert this to make our work easier? We have to convert what we have into seconds and then make sure it's in powers, right? So let's see, 20 hours. So this we have in 20. I'm just doing this to make our work clearer. So 20 according to seconds times 60, right? Times 60. That's what we have in 7200. Right. So let's divide by 10. Let's see. This is what we have, right? And then we divide by 10. And then we have all this. We're trying to get the maximum tens out of it. So let's see. Any zeros out of it. So let's see. 1, 2, 3, 4. Right. So we can divide it by 10 to the power what? Do you get what I'm saying? We are just trying to make sure we get every 10 as much as possible from it, right? So times, so that will be divided by 10, so because we have what? Let me do this one. We have 101010, right? We can go one more, so we have 7.2, 10 to the power what? 4, right? We went 4 times, so we have 7.2 times 10 to the power 4. That's what we are having for the 20 hours, right? So we have 10.4, now 7.2, right? So 7.2. So this is what we do. We know this are 10 to the power 4, so 7.2 will be somewhere here, right? So we know this to be 5, and 7.2, let's say 7, will be about here, right? So after we reheated to this, what's the name? 700, we hold for up to this side, right? So here, which is about this one, right? 20 hours. Whenever you hold austenite, right, at a higher temperatures, like about seven something, right, about 700 to about like 720, 750, you get a structure called spheroidite, right? So that's what we have here, spheroidite, right? But then again, there's a way to convert bainite and then what do you call it, perlite to spheroidite. But when you're converting directly from austenite to spheroidite, this is how we do it, right? What do we get? So now we are at E, right? E, let's see. E now. Now what's E saying? E is saying that we rapidly cool to 300, right? Where's our 300? We are here to write we rapidly cool to 300, right? And then what do? We hold for 20 seconds. 20 seconds is clear. We know this is 10 to the power 2. 20 seconds should be like, if the year is 10, meaning we are going, every one mark here is about, what do you call it, 10, right? So here's 10, 20 is about here, right? So we hold for that 20. Let's see, right? 20 seconds, and then we are E, right? And then we quench room temperature in water. Whenever we are doing a quenching, meaning we are cooling rapidly, so it doesn't take much longer because from here to here is a very short time, right? So let's see, a very short time. So it should be short, right? Quench room temperature in water. And what do? Now we say we reheat to what? Then again, remember we've quenched, we've held, and then we are going back to under temperature because we consider time. We have to what? Zero, right? 425. 400 is here, 450 is about here, and 45 will be about here, right? What they say. So now from where we've ended, we reheat to 425, which is about here. So what do? Right? And then what do? We hold for 10 to the power 3 seconds. And slowly, remember this, slowly and rapidly are different. We get it. For 10 to the power 3 seconds, right? So 10 to the power 3 is about here. Let's see. Right. Let's make this clear. The time is very important. So let's see. I'm trying my best to make it as straight as possible. When I'm doing it on paper, use a ruler. It's best. Helps you to keep your understanding, right? Tend to about it, right? And then slowly, whenever you are doing something slow, you see all these slants here are very, what do you call it? They're having a very, what do you call it? Small slope, right? The slope is not that wide, not that big, right? The gradient is not that, what do you call it? The gradient is steep, right? So now that's for rapid. Because it's saying slowly, it takes a longer time, so it will stretch, right? So it will be something about this. To room temperature, it doesn't matter what happens, so we just make it white so that it's sensible, right? This shows that it's slow, right? Then again, what structure did we get for we are on E, right? So let's go by it. We are still in austenite, so we started from the 760 right here, and then we go here, still austenite, right? And then we held it for some time. We are still having what? We've not, what do you call it? We've not started binary transformation, right? So we are still having austenite, right? And then we quench. Because we quench all the, what's the name? All the austenite will tend to what? Martensite, 100%, right? And now, what do? We raise it to a particular temperature, about 425, right? And we held it for some time. Because martensite won't convert to, what's the name? Martensite won't convert to perlite or bainite, right? It can only convert to, what's the name? Austenite when you raise it up to a temperature about here, austenite region. But here's the case, we only raised it here, right? And we held it for some time and then we lowered it back. When you do something of this sort, we get what we call a tempered martensite, right? So that's what we get, 100%, nothing else, right? Everything is martensite. So here's what we get, 100% martensite, right? Sorry, tempered, because we raise it up a bit, right? Tempered martensite, right? Let me write this out clear. 100% tempered martensite. And then all of these structures of iron carbon alloy, They have their own structures, but here we are just doing the transformation how to identify them in what do you call it, temperature time transformation, right? Uh-huh. Now we are F. What's F saying? A minute. F says rapidly cool to 625, hold for 10 to the power 3. We start from here again because this is the reference, right? 665 rather. So here's 600, 650 is about here. 665 is somewhere about here, right? So this is 665. And then what do? We hold for 10 to the power 3. That's clear. We can find it with ease. Let's do this up. 10 to the power 3. And what do? We are accurate. And then we quench room temperature. So that's what we do here. Quench. Whenever we say quench, it's like rapid cooling, right? So what happens here? Guess. So we have 100% arsenide, right? And then what happens? We are still in the, what's the name, perlite region, right? We hold, and then because we've crossed the middle, we've crossed the end point, we get 100% perlite, right? And then we quench. Perlite doesn't transform to martensite, so what do we have? What type of perlite is that, right? We know the boundary of the fine and coarse perlite to be 650, and when we are above the, what do you call the 650, so what do we have? Coarse perlite, right? So 100%, 100%. Sorry, here is 100% spheroids, right? Uh-huh. And then you have 100% what? Coarse. Remember, the percentages are very important. Without the percentage, we don't know what you're talking about. It could be a different structure. So let's do this right. Very, very important, the percentages, right? So they have here 100%, that's 100%, right? Spheroids, was it? Spheroids. Now let's go back to our brother here. So 100% course were perlite. That's what we have here, right? Now G. We'll check what G is saying soon. What's G saying? G says rapidly cool to 575. Make your work easy. We know 500 is here, 550 is about here, right? 575 will be exactly here, right? And then what do? We hold for 20 seconds. 10 is here, this 100, so we count, right? Here's 10. Just move one, that's 20, right? So we are about here, right? Yeah, we hold for 20 seconds, so that's it. And then what do? We rapidly cool to 350 because we've held, we are going to enter temperature. What do? Re 0 to 350. What 350? 300. 350 is about here. So re 0. And now we are here. What do? We hold for 100 seconds. Where's 100? 10 to the power 2 is 100, right? So that's where we go, right? Let me put it below so that we see the color clearly. Now 100, right? And then what do? We quench room temperature. Quench meaning short time, so we don't take that much long. So about this way, right? So what do you think we have? We started from here. What was the beginning? Rapidly cool to 575, right? So rapidly cool to 575, right? That's it. And then we held it for some time. We will have, what do you call it? 100% or perlite. What do you think? Is this so? Yeah, because we crossed the middle 50-50, we go here, so we're having 100% war. What kind of perlite to be exact? Fine perlite, right? Because we are in this region, right? You can go back and check. 100% fine perlite, and then we re-zero, right? And then now we hold. Even though we are holding, perlite doesn't convert to what? Martensite. Sorry, bainite, right? So after we get the 100% fine perlite, whatever you do to it depends. So what we are doing to it here, from the 100% fine perlite to here, re-zero, and then to here, it doesn't change to bainite, right? So, and then perlite doesn't transform to martensite, right? So we are still having 100% fine perlite, fine perlite. Then again, that's why at the beginning what we're doing was very important. When you get those concepts, whatever the transformation, you'll be able to determine the structure that you have and their weight percent, right? Yeah. Now what do we have? We are at H, right? We are done with G. Yeah, H. What's H say? Rapidly cool to 350. Then again, you don't always have to draw this, you just have to follow somehow. So we know 350 is about here, so we are starting from somewhere, let's see here, right? Let's use a different color. Let's see, what do we have? Yeah, blue. So 350 is about here, right? If rapidly cool to 350, we are holding for 150. So you see 150 is not directly there. So how do we go about that? So for stuff like this, don't try to think that much. I do not see because you have to focus on seeing what's actually in the diagram. So you can use your calculator to help you out. So how many can we go? So we can take this out, take this out. So we divide by 100, right? So let me do this so we see what's happening. You remember this stuff where we have something like this, right? And we are trying to get as much as possible the number of tens from a multiples of 10 from it. So this, right? So we end up having 1.5, right? So that's what we are doing in the calculator. It's just the same thing, divide by 100. So you can just move that way and then you'll be fine. So we have, well, and this 100 here is the same as 10 to the power 2, right? And we have 1.5. So that's what you do. Since you move 2 times, right? Let's do this again. So it's clear. You have, well, 150, right? And then you moved, I'm coming in. We have a 150, and then we move on to 1 2, so that's 10 to the power 2. And then what do we have after moving? We have 1.5. So the end is 1.5 times 10 to the power 2 is the same as that 150 seconds that we have, right? So where's 10 to the power 2? This 10 to the power 2, right? 10 to the power 3. And here's their middle, so that's what do you call it? 5, right? Here's 5. But what do we need? 1.5. So the middle will be about 2.5. 1.5 will be about here, right? So that's the way to find what do you call it, the times that are not directly given in the diagram, right? So what's the name? 350 code for 10 to the power, code for 150, right? So this 350, right? This 350 is here, hold for 150 seconds. What will that take us? About here, right? Let me do this well. Then again, use a ruler. When you use a ruler, your work is much more neat, right? Yeah. And then what do we do? Quench room temperature. Quench meaning short time, doesn't take that much long. Looking at this, the two, what do you call the 1.5 is about here, so we should be here, right? So we can then approximately say we had 100% austenite, right? We cool to this side, and then we maintain, yeah. So we cool to this side, and then we held it for that temperature for this long, 150 seconds. What do you think we have? We have what do you call? We are in the bainite region, right? We have 50% converting to bainite, right? And then when we quench, the rest of the 50% austenite to convert to what? Martensite, right? So that's what we have each, right? So we have 50% bainite. But what type of bainite? Just to be clear, the fifth, the what do you call it? We know bainite is from about where this line ends, right, to where what we call 350 here, and then we know where the upper and lower bainite meet is about 350, right? So that's just by the way, we know that now. So meaning that we have a medium bainite, right? Mean like kind of like a mixture of what we call upper and lower bainite, so medium, right? 50% medium bainite, right? And then the rest of 50% will be what? Because we've quenched the rest of the austenite, which is 50% to convert to what? Martensite. So 50% martensite. Yeah, so that's about it, right? So let's see if we're on the right path. Let's see. So let's see. Right. So first one, 100% bainite. You see, they are not that. These are conversions. So that's what I was saying earlier. 50% medium perlite, right? 50% martensite. C, 50% fine. 25% upper bainite. 25% martensite. Right. D, what's D saying? 100% ferrite. E, 100% tempered martensite. F, 100% coarse perlite. And then G as well, 100% fine perlite, and then what do you have for each? 50% medium benign, 50% martensite, right? So that's it. All right.